Welcome. Today we solve some problems on set relation and mapping on this chapter. It is part 2 of that chapter and it is for competitive exams. Our first problem is say A 1, 3, 5, this set, one set of all odd natural numbers. B is the set of 2, 4, 6. This is set of all even natural numbers. Then and fx is equal to mod of x minus 2 plus 1. Then f function a to b, this function is number 1 onto and but not 1 1, 1 to 1. Second option is bijective. Third option is only 1 1. Fourth option is none of these. None of these. NOT. None of these. Okay. Now let us start the problem. So one function is given here. It is the functional law is mod function, some mod function. Then we have to alert that it may not be 1 1. Here in option 1 1 is there, 1 1 is there. Bijective means 1 1 and onto. So we have to find out whether it is 1 1 or into or onto. About 1 1, if I can say that, if I can prove that for more than one values in A, fx gives exactly same value for B. If this is the case, then it is not 1 1. In that case, if I take x is equal to 1, that is f1, it is mod of 1 minus 2 plus 1, minus 1 is plus 1 plus 2. F of 3, it is equal to mod of 3 minus 2 plus 1. Once again it is 1 plus 1, 2. So it maps 1 to the point 2, 3 to the same point 2. So it is not 1 1. So not 1 1. So this case is not possible. Bijective is not possible. This is not possible. This is not possible. Now we have it is not 1 1, that is proved, but we have to prove that it is onto. Onto means in set B, every member, we have to prove that every member of that must be some image point of one or more than one of these. For that purpose, let us take that the B is a member for B, capital B. Let us take B is a member of B. That is, B means that B must be even in positive integer. And corresponding to A of small a, its image is B. So we get B is equal to mod of a minus 2 plus 1. So we get a minus 2 is equal to b minus 1. It is an odd number, you see, because b minus 1 is, b is even, so even minus 1, so it is odd. So by solving this, we must get one or more than one value of A which is odd, that is which belongs to A. So all members are image point of one or more than one or 2 points from there. So this is on 2. So ultimately we get this is on 2 but not 1 1. This option is correct. Our next problem. If fx is equal to log x base e gx 2x minus 1 and hx is equal to x square plus 2 and f, the function f, r plus 2r. R plus means positive real number, 2 real number. G is R to R, H also R to R. Then H G F 1 is 1, 2, 3, 4 are the options. Three functions are defined here. One function f, r plus 2r, g, r 2r, and so on. Log fx, gx, hx are given. Then we have to find this value. This problem is very simple. This is equal to h composition g composition f1 is equal to f1, very simple. F1 is equal to log 1 base e, that is 0. So it is h composition g0. G0 very easily we can calculate. G0 is equal to minus 1. So it is h of minus 1. H of minus 1 is equal to, can be calculated from there. It is minus 1 square, 3. 1 plus 2, it is equal to 3. So third option is correct. Next one, next problem. No. If R to R and G R to R are two mappings such that fx is equal to e to the power x and gx is not given, but given thing is g composition f of x is equal to e to the power 3 e to the power 2x minus 1. Then gx is that fx given, gx to be calculated, and options are x cubed minus 3, x square minus 1, 3x minus 1 whole square, and 3x square minus 1. Okay, 3x square minus 1. Somewhat it is a reverse type problem. Fx given, gx is not given, but G composition F of X, this is given to calculate Gx. Now, from the given relation, 3 e to the power 2x minus 1 is equal to G composition Fx. It is equal to Fx means e to the power x. So it is G of e to the power x. Suppose e to the power x is equal to say y. Then we get from there Gy is equal to 3. It is e to the power x whole square means y square minus 1. So Gy is equal to that. Hence Gx is equal to 3x square minus 1. Fourth option is correct. Our next problem. If F mapping F R to R not R to R, it is from S to S. R is, if not defined, R is set of real numbers, S to S. Now S is defined here now. It is where S is equal to X such that X not is equal to minus 2 by 3. S actually set up all real numbers except this. And Fx is equal to 1 minus 2x by 2 plus 3x. Then F inverse is, we have to calculate, and a function is given, we have to calculate it inverse function. To calculate inverse function, the law for function Fx is equal to that. From this, if we take Fx is equal to y, this is equal to 1 minus 2x by 1 plus 3x. From this relation, taking this as y, solve x in terms of y. That will be the inverse function. So it is 2 plus 3x. This is not 1. So y into 2 plus 3x is equal to 1 minus 2x. So that we get 3yx plus 2 into x is equal to 1 minus 2y. That is x is equal to 1 minus 2y by 2 plus 3y. This is x in terms of y. So our F inverse x is, we have to write y in terms of x. It is, we have to write y in terms of, instead of y we replace by x. So it is 1 minus 2x by 2 plus 3x. That is the function, same function, it gives the same function. Oh, there are some options. I felt I forgotten to give the options, but answer is this. Now for the next problem. A is equal to 3, 4, 5, one set. B, oh no, and on set A, one relation is defined as 3, 4. That is 3 is related with 4. Then 4, 5. Then 5, 3, then 3, 5, 4, 3, 4, 5, then 4, 3, 4, 3, and 5, 4. This is a relation, means this is one subset of A cross A, where A is that. So this is given. Now to find whether that relation is, now 4 options: reflexive, but not symmetric. I'm writing in this, symmetric only. Number 3, transitive only. And 4th option is symmetric and transitive both. So now let us see one by one. First thing is, it is reflexive. To prove it is reflexive or not, reflexive means x relates with x for all x belonging to that. That means 3, 3, 4, 4, 5, 5 must be there. But you see, at least 3, 3 is not there. So it is not reflexive. So this is ruled out. Next, try for symmetric or not. Symmetric means if 3, 4 present, 4, 3 must be present. It is there. 4, 5 present, 5, 4 must be present. It is there. 5, 3, then 3, 5 present. It is there. So it is symmetric. So we get symmetric. Then let us see transitive or not. Transitive means if 3 relates with 4, then that is 3, 4 is there, then transit and 4, 5 present, then 3 to 5. 3 to 4, 4 to 5, so 3 to 5 must present. It is there. Then 4, 5, 5 to 3, so 4 to 3 must be present. Yes, it is there. Now 5 to 3, then 3 to 5, so 5 to 5 must be present. 5 to 5, but it is not there. So it is not symmetric. It is not transitive. তাহলে we get it is not reflexive, it is symmetric, but not transitive. So our second option is correct, symmetric only. Next problem. A and B are any two sets. A and B are any two sets. Then A union B, its complement meet B. That set is options A, B, A meet B, and null set. So this type of problems can be solved very easily using Venn diagram. Here, this case will be rather very easy if we use De Morgan law. De Morgan law is A union B complement. It is A complement meet B complement, and then meet with B. So this is this and meet B. Now you see B complement meet B, it is a null set. So they together is a null set, and null set with any set is null set. So it is null set. Next one. Let F R to R is a mapping where Fx is equal to x square minus 15x plus 23. Then F inverse minus 33 is, so law is given, Fx is equal to that, and it is from R to R. So all real numbers are involved. So Fx is equal to this, then to find the values of x such that its reciprocal, inverse function is minus 33. That means we have to find all values of x for which this become minus 33. That is, we get x square minus 15x plus 23 is equal to minus 33. So it is x square minus 15x plus 56 is equal to 0. Very easily we can factorize them. It is x minus 7 into x minus 8 is equal to 0. So x is equal to 7 or x is equal to 8. So x is equal to, for x is equal to 7 or 8, its inverse function is, will give the value minus 33. So option is 7, 8. Next. The mapping F A to B, where Fx is equal to sin x, law is Fx is equal to sin x, and A, the set A is minus pi by 3 less than or equal to x less than or equal to pi by 3, and B is the set from minus root 3 by 2 root 3 by 2. Then the function is 1 1 onto, it is given 1 1 into 1 1 and into 1 1 and onto. Third option is many 1 into. Fourth one is many 1 onto. So 4 options are there. Actually, one function is given, mapping is given, A, B, two sets are given. We have to find whether the mapping is 1 1 or into 1 1 or many 1 into or onto. 4 things we have to find, and then combining them we can get the result. So you see the function is fx. It is 1 1 if a function is linear in x, right, like say 2x plus 5 linear, it is 1 1. For trigonometric functions, it will be if the function within the range this to that, if it is increasing function or it is decreasing function, then it is 1, 1. Let us see whether this function in that range is increasing or decreasing or nothing. If nothing, we cannot say anything. Now, for to be increasing function, find f dash x. This is cos x. And range is minus pi by 3 to plus pi by 3. The entire one lies in fourth and first quadrant. Some part of fourth and first quadrant. Cos x is positive over there. So cos x, it is positive. So function is f dash x is positive, means fx is increasing function. So this is increasing function. So it must be 1, 1. Either 1, 1 into or 1, 1 onto. Now two options, either 1, 1 into or 1, 1 onto. Now we have to find whether it is into or onto. For that purpose, the value of fx at minus pi by 3, that is initial point, it is equal to minus root 3 by 2. And for this end point pi by 3, it is plus root 3 by 2. That is, the function assumes this and that at the end points. And just now we have seen that the function, if sin x is continuous function, sin x, cos x, they are continuous function everywhere. So it is continuous function and it assumes this value this and maximum value that. So as it is continuous function, so it must assume all values between this to that. That is, all values between this to that. That is, it is an onto mapping. So answer is 1, 1 and onto. This one. Next. Let f R2 R plus, where fx 1 plus e to the power x by 2 is a mapping. Now, this mapping is surjective, SUR, surjective and injective. Means surjective means onto and injective means 1, 1. Then second option is injective but not surjective. Third option, not injective. Not injective but surjective. Neither injective nor surjective. So one function is given, one mapping is given, then we have to find whether it is either injective 1, 1 or many 1 or into or onto, etc. We have to find it, and then after that, from our result, we can say whether it is this or this or this or that. So first of all, we have try to find whether it is injective means 1 1 or not. Now you see this function is increasing function. Fx is equal to 1 plus e to the power x by 2. It is increasing function. So it must be 1 1. So it is 1 1. So now into or onto, it maps to that point. R to R, it maps. R plus means all positive real numbers. Now, law is this. So for any real value of R, e to the power x by 2, this is positive. 1 plus positive quantity is always greater than 1. So very clearly, the function has no image point between 0 to 1. So 0 to 1 for this set R plus, 0 to 1 for all such infinite number of points, they have no pre-image point. So this is not onto mapping. This is not onto mapping. That is, this is into mapping. So our option is, which one is correct? Say injective but not surjective. Injective means 1 1. We proved. Not surjective. Surjective means onto mapping. This is not onto mapping. So it is 1 1 and onto. So it is injective but not surjective. The definition, all these type of definitions, injective, surjective, etc. This you have to keep in mind always. Thank you for today. If you feel that this will help you, so please like it, share the video, and subscribe the video if not already subscribed. Once again, thank you.